Thank you for hanging around. I just realized that we can start deep in the subject. So I realized that I'm on the program committee since you just mentioned it, and I wanted to thank the program committee for inviting myself. So that means we have a conflict of interest to declare right upstream, which we will discuss further in a moment. So I'm pleased that we're here to critically discuss a rather important, albeit not always very pleasant subject, which is research ethics, and something that affects all of us in publishing. But of course, it's not a publishing problem per se, it's a research problem. So, so we will discuss the various layers of research that are involved or should be involved in the process as part of the discussion, and I think it will be very useful. We will aim to come to hopefully a point where we can have some convergence on thinking, and hopefully even possibly leave with some consistent policies or thoughts at least on policies that we can all share, because at the moment it's a real mess, to put it mildly. It's a wild west out there of everybody doing what they see fit. And that's not ideal, because it's really affecting research and especially the credibility of research in the public, where our funding comes from. So it's turning into a real crisis. So we've decided to structure this as an inordinately long session, because there was a lot of talk about the increase in funding in China, and that clearly hasn't percolated up to the travel grants because they've all canceled their trips. So the Chinese session was canceled, so we actually phagocytosed it, and we've just extended our session. So we have quite a lot of time to discuss a very complex topic. So if you start getting, if I start seeing people nodding off, we will sort of come to a close a bit earlier than the scheduled time. So do hang around and do show if you're getting bored, then we can sort of wrap it up. We decided to structure it into three parts, which is short statements, hopefully short statements by all the panel members that should take us no more than 50 minutes. We will follow that with a more structured panel discussion to make sure we cover some of the important points that we need to discuss. If you have comments to make at that point, we will involve you already at that time, but we really wanted to reserve a good chunk of time at the end to open up the discussion to the floor. And so please prepare comments, statements, or questions that you want to throw at specific panel members or at all of us at the same time. So without too much further ado, I will go on to introduce the panel members. So we have Richard van Noorden, who's the deputy news editor at Nature. He was an old colleague of mine at Nature. He used to be a journalist in the field and is now a senior editor of news pieces. He's reported quite a lot on issues of image, not just image, of research ethics, so he's very well placed to comment from an overview. We have Chris Graf, who's the co-vice chair of COPE, which is the Committee of Publication Ethics, which is a not-for-profit, of course, association of folks associated with publishing who meet regularly. So if you haven't heard of COPE, I'm sure he will introduce it a little bit. It's a very important organization. We have Peter Görlitz, who is the editor-in-chief of Angewandte Chemie. We'll bring in the chemistry angle, a huge journal. So it's a lot of these problems are about scalability, so I'll be very interested to see how they handle things. Anne Kitson, who's the executive vice president of health and medical science publishing at Elsevier. Catriona McCallum, who's the PLOS acting advocacy director, and she comes out of editing also. She's a biologist, an epidemiologist, and will comment on what PLOS does. PLOS has been quite proactive also, as has Elsevier actually on these matters, which is why they're on the panel. And finally, I am Bernd Pulverer. I'm from EMBO, which is the European Molecular Biology Organization. I'm both the chief editor and the head of our 4 journals there. So I wanted to give you a very quick introduction so we're on the same page. What we define as, well, certainly, sorry, what I define, I'm speaking for myself, you can contradict me. What I define as research ethics is both the ethical conduct of the research, which involves the experimentation and also how credit is given to the experimentation, and the ethical reporting of that research. And that includes of course, falsification, fabrication, and plagiarism, which is the acronym for this is FFP, and it's this is the definition, the most official definition we have from the Office of Research Integrity in the US, which I won't read out. But you can see that every stage of the research enterprise is involved in the definition. And then, of course, it extends to research assessment and publishing. So referees can breach ethics, editors can breach ethics, and journals can breach ethics issues. And importantly, a related topic that we really want to touch on today too is reproducibility. And this has really come to the forefront in the last year, I would say, as certainly in the biological sciences, as a key issue, a perceived loss of reproducibility in the published literature. So to summarize this a little bit, what we find, so I cover journals that are in the molecular cell biology arena, so some of the things I say may be a bit more specific to that. But we are finding quite often that the tail was wagging the dog was mentioned in the last talk. We're finding that a lot in the research that we see submitted. So we're finding that classically biological researchers formulate hypotheses that they go out to disprove. It's called the null hypothesis. They test the hypothesis. What we find is experiments are often done to support the hypothesis in the most efficient way, to get the paper out as quickly as possible, get the next grant, and formulate the next hypothesis to support. That's a bad way to do research, and it's driven by research assessment, this vicious cycle. Unbiased reporting is also a culture that we seem to be drifting a little bit away from, because people are educated these days to tell stories in their research papers, which often oversimplify things. And complex biology is very complex and noisy data. And to report things as they are, as you saw them yourself, which is what you should be doing as a researcher, is a tough call, because you may get rejected for that. So we have to grapple with this at the journal level. So just to give you a couple of illustrations of the sort of things I'm talking about, which is causing a lot of work for journals, but it's also a great opportunity for journals to play an important role, is to look out for issues with the ethics of the experimentation itself. So things where policies and basically rules, the rule of law is breached. So for example, here's a paper from EMBO journal where they followed the venerable tradition of doing experiments on themselves. In this case, unfortunately, the PI did the experiments on the students in the lab. And that's something that was completely legitimate and IRB approved in the country of origin of this research, which happens to be where we stand, but is of course not allowed in many other countries. But you immediately see the tension here that an international journal has to make a decision then which country's rule of law it follows. So that's very difficult. And this was an unnecessary cruelty. I mean, this experiment up to 8 out of 10 of maximum imaginable pain. So it's not exactly just a little pinprick in the finger. And what we see very often, we have 4 journals and we're doing systematic pre-publication image checks now, which take quite a lot of time. And the sort of thing that we typically see is people who are messing around in Photoshop and dropping in and taking out selectively information from experiments. The problem is that we see this quite a lot. So we can't really go back now. We're seeing in about 20% of the papers that have gone through peer review and are otherwise publishable, we see some level of problems. So this is something, and the beauty of why we feel we're really adding value is that we can sort out more than 98% of these problems. So a lot of these problems turn out to be due to sloppiness, misinformed way to do research. Just to show you that it is difficult, though, because we have to make judgment calls all the time, and this is why we need to talk about this more systematically between editors. We have to make judgment calls. We see data like this, and it looks all fine. These are little cells that are stained for DNA. It all looks kosher until you do a few Photoshop manipulations, and you see that half the signal was actually rubbed out with the Photoshop rubber tool. This is, of course, selective data reporting. They could have done this upstream, not included certain views of the cells also. So there's many ways you can manipulate the information you share that we can't possibly see, but here you can see that they did this. So what do? Is this fraud, or is this an extreme form of beautification of the data? So we take off these rubbing things, and we have to interpret the data and see what they rubbed out, and then come to a conclusion if it's fraud, if they're misleading us, or if it was just a really, really stupid thing to do, and we can correct it. And here you can see Edward Munch's face, I just noticed. So this is probably a telltale sign that there is a ghost in here. I also want to make the point that it's very easy to jump to conclusions when you see problems. And I used to work at the journal Nature, and when this happened, Photoshop is really fun. And of course, you want to play around. And when we published the Dolly the sheep, the first cloned mammal, we unfortunately inserted its partner's leg in a rather obscene place. I'm not sure if you can see that. So it's actually 2 sheep, but only one of them was cloned. So this is what happens, and one has to be careful with Photoshop. Quick point about reproducibility. Various estimates seem to show the shocking number that only 30 to 60% of the published important, what's sometimes called milestone papers in all kinds of areas of research. That includes cancer, that includes various medical sciences, but also sociological sciences, are reproducible these days. That means the rest is not reproducible. That's a really scary number. The question is, what's it based on? It's actually very difficult to analyze this. So there is now a very well thought out not-for-profit enterprise that's called the Reproducibility Initiative, that's testing papers in the social sciences and now cancer systematically for their reproducibility. And this is a very interesting experiment in social sciences. They just published their findings in the journal Science. In cancer, they will publish soon, and I would assume they will find something very similar. It costs something like $26,000 per paper to try to reproduce it, so you can immediately see it's an entirely unscalable solution to sorting out the mess. But still, it's probably interesting to test 50 papers. The problem is what will come out of it. They will have a number in the range, I assume, again, of 30 to 50% in cancer research. It will go straight again on the cover of The Economist that will declare science is broken. And this is what our politicians read and who decide on our funding. So it's very important to remember that reproducibility is a very, very complex issue. And just to illustrate this with one example, these are very well known researchers who were collaborating for many years, and they could simply not reproduce each other's results. One specific results they could not reproduce. One is on the East Coast, one is on the West Coast of the US. After 1 year, it turned out that it was the way they were shaking their culture flasks that made all the difference in the experiment. And they actually published a paper on it, so it's great. They got some credit for it, which is good. But it took a year out and possibly several research careers to sort this out. But it is important because even though they're working on the same topic, they clearly, it took them forever to work out what the variable was, the deadly variable that caused the change in the reproducibility. Now the data stands and the conclusions are solid because it could be reproduced, but it took a huge amount of effort. So you can immediately see the Reproducibility Initiative would have probably deemed this paper to be not reproducible. So it's important that we grapple with this at the journal level as best we can. We have to find ways to ensure that the methods we report in papers and the reagents are as accurate as possible and has as much detail as possible so we can follow protocols. We have uniquely identifiable reagents, ORCIDs for reagents, basically. There's many things that we have to do. And the way we publish papers at the moment does not render them very reproducible to start with. So what are the causes of some of these things? Very importantly, it all comes back to the same topic which we discussed in the previous talks, which is research assessment. We've discussed in various talks at this meeting the increased number of researchers, the decreased funding. That means the competition is going up. Research assessment is deferring to metrics to try to have a more objective way to assess things, and in the process have thrown out the baby with the bath and become less objective. We've tried to address this before and quite successfully, I think, as best we can in the San Francisco Declaration on the journal impact factor. But that doesn't solve everything, of course. There is a rush to research, at least in biology. The paper is often seen as the end goal because that's the measurable outcome that will be used in a research assessment. The goal is not anymore the long-term reputation. Since reputation was mentioned, it's the short-term reputation that you gain from your research because people are under pressure. There is a lack of training, and I think that's a really important root cause. So, and again, training is a classic top topic that we can go into as publishers also. So I think there's a huge lack of training in biology. It even moves up to the senior investigators now who are lacking particularly statistical training. And there's a lack of detection of problems. So people know they're getting away with murder, and they do. And so when things are detected, there's a lack of consequences often. There's also a huge amount of ambiguity, and this is what I hope the discussion will cover today a little bit, to have a more absolute view of what is actually fraud, what is beautification, and what are mistakes, excusable mistakes that can be corrected. Okay, and I'm going to wrap up now. The stakeholders involved, why is this so complicated? Because so many stakeholders are involved, from the laboratory that generates the research to the scientific community where your reputation matters so much, to the institution and employers who are meant to be tasked with doing investigations on research misconduct, but often fail or not able to do this properly and in a neutral manner, to funders and governments who usually excuse themselves from this altogether. So it would be good to discuss what their role actually is. And to the journal. And this is complicated by field-specific heterogeneity, of course, and issues with nationality, like the rule of law being very different. So what happens is it all deflects down to the journal. This is the last checkpoint before something enters the literature. We are the guardians of the literature, so in the end it falls to the journals often to sort out the mess. This is the problem, as John Sack pointed out. We want to decrease friction, not increase friction. So all this pre-publication checking stuff, the author checklists, with Richard we'll also talk about, cause extra friction, and they cost extra money. So if we are driving down the cost of publication, that's not something journals will be encouraged to do. So we will discuss a little bit if we need bigger structures, neutral bodies of experts that will actually help us with all of this. To finish, it's important that we question actually if the big dogma in academic publishing of the self-correcting literature, which is a really basic tenet of publication, if that still exists. So if what percentage of the literature is reliable now? Is retraction the right mechanism to deal with problems? Do we need a more differentiated way to correct the literature than just retractions? And what about all the papers that are out there in the more than 1 to 2 million papers published every year in STM that are just simply sitting there, that are not reproducible? So we need to encourage corrections and retractions. We shouldn't discourage them by making them difficult. We have to really strongly encourage them. We need to publish refutations and negative data more proactively, and we need to enforce policies such as reagent sharing and curate much better the information we publish to avoid spin and hype and selective reporting. And I would strongly say that, and this came up in several talks, that we need versioning on our papers as a more forward-looking way to publish. Okay, and now I would like to invite the next speaker up, so Catriona will come up, and then we run through the